In this tutorial, we're going to look at a few ways to edit targets after you've created them. From our previous tutorials, we've created some targets from a curve, but maybe they're just not quite what we were expecting. In that case, one of the easiest ways to edit our targets is through the transform target component. It offers several different ways of realigning your targets to face vectors, curves, meshes or surfaces. I'm going to stick with a line parallel to vector just to show you how it works. I'm going to make all of these targets face the origin, where the base of my robot is. What I'm going to do is grab my target properties to find out where the targets are. The end frame here is the location of the target expressed as a grasshopper frame. So what I can do is create an XY plane and a vector 2 points from the end frame towards the origin. I can now use that as the direction vector for the parallel algorithm, and the targets that I want to modify go in there. We can see they haven't all pointed in the right direction. That's because the axis is currently set to Z. I want to use X, and we can see they're all facing straight towards the origin. We can also flip these vectors if we want to, so they all face the opposite direction. If I don't want these to be facing perfectly towards the origin and just orientated towards 0, 0 on the x-axis, but keep their plane, I can deconstruct the vectors and remove the Z component. One of the other useful aspects of the transform target component is the free transformation. Here, we simply pass in the targets and the transformation that we want to apply. Here, if I set the Z transformation to -100 or anything else, you'll see that they move. It's important to note that the reference of this transformation is the target itself. So you'll see as I go up in the Z displacement, the targets are moving in the positive Z according to them. If I want to transform these targets by any other reference, I can simply set the reference parameter, and now when I move the Z up, it will move up in the Z of the world. One other useful thing we can do applies if we have too many targets. Here I've managed to, very simply, divide a curve into too many targets, and they're not going to add anything useful to my program, and they're only going to slow down my calculations and export, and maybe even my robot. We can use the target filter component to filter the targets down to something slightly more reasonable. The display of the target filter component is all the targets, both those that remain and those that have been discarded. But here we can see, if I filter these to the nearest centimetre, we have considerably fewer targets remaining, 70 instead of 7,000. I can change the position or orientation filter parameters so that I get more or less accurate readings and sampling of that original series of targets.